In Unit 1, Homework 9, we're looking at application problems that basically cover all of the work that we've done before this in Unit 9. One thing to keep in mind is sometimes you won't see that it's a familiar problem until you start doing some work. We can't run through every type of problem in this section, but I'm going to go through and kind of show you some strategies for working with these problems. And again, they're all application problems, so a lot of times you're reading graphs or choosing a function or using a formula. We will not be having a lecture quiz over this section. Because there's no really new material, it's just learning how to read graphs and apply the material we've already learned. For this first question that we're going to be looking at, again we have a graph, and on this graph it's giving us some number of times that a particular group of people awake during the night. And so women we can see here is in red because the word is in red, so that tells me that the red part of the graph is what I want to look for women. The blue is in men, and it's in a blue type, and that's also associated with a blue graph. Now my question over here is women have the most numbers, so we want to look for who are we looking at, men or women in this case. Women have the most number of awakenings during the night at age of, well, if we follow through with this graph we can see that the red graph is highest at this point right here. Okay, so that's kind of what we're looking at. Now it's asking for the age, and so the age is on the horizontal axis. And if we come down, we can see that each of these tick marks is worth 10 units, so this would be 50 here. And our tick mark is halfway between 50 and 60, so that would mean at the age of 55 they have the most number of awakenings during the night. Now part 2 to this question is also going to ask you something. It will say, okay, at the average number of awakenings, what is the average number of awakenings per night at this age? So at this age we can talk about the average number of awakenings per night by reading the horizontal axis, or sorry, the vertical axis. So that's the next question here. Now if we read straight across from here we can see that that's going to be a 6 here. So 6 would be the average number of awakenings per night for a woman who is 55. So again, you have to be careful when you're reading the graphs. It's a good idea to explode these graphs, making them larger by clicking the magnifying glass if you have trouble reading them. Let's go ahead and look at another type of problem that you'll be running into. For this next problem, go ahead and pause the video and read through the question so you thoroughly understand what is being asked, because sometimes a lot of times we just look at a problem and we want to come up with a solution right away, but it's important to read through everything. So for this one, this bar graph on the right hand side is talking about the percentage of adults in a certain city who smoke cigarettes for selected years from 1970 through 2010. Then it gives you this mathematical model that describes the percentage P. So P stands for percent. That's going to be important. Of adults who smoke cigarettes X years after 1970. Okay, so X is not just the year, it's the number of years since 1970. And it says to use this model in the graph to answer the questions below. So let's see if we can relate this information from above to this question below. It says, does the mathematical model underestimate or overestimate the percentage of adults who smoke cigarettes in 2010? Okay, well we don't know the percentage, so that's kind of our unknown. So I'm looking after my model here, or my formula, and I'm trying to figure out what can I plug in. Well, P is my unknown, but X I can figure out. X again is the number of years after 1970. So I could take 2010 minus 1970, and that's 40 years, and that's going to be what I plug into my formula to solve for P. So I have P plus, instead of X over 2 though, I have 40 over 2. Because again, it's 40 years after 1970 in 2010. Equals 39, and then I just solve this as usual. So I have P plus 40 divided by 2 is 20 equals 39. Subtract 20 from both sides, and I have P equal 39 minus 20 is 19. So we come up with the model says 19% in 2010. Now let's go ahead and look up here at the graph. The graph says, and this is the actual data versus our model, we're looking here at 2010, the graph says 21% in 2010. So if we look at what we have here, our model, it says the model underestimates or the model overestimates. Our model is lower than the graph, so we have underestimates the actual value. The difference between 21 and 19 is 2%. So the model underestimates the actual value by 2%. So that's our first question that we're looking at here. Now the next question is going to basically ask, okay, use the model to project the year in which only, let's say, 6% of the adults will smoke cigarettes in this city. So what we want to do is we want to use our model again, but in this case we know the percentage. We want to find the number of years. So again, we start with our model. P plus x over 2 equals 39. And this time I know the percent. So that's what I plug in. So I have 6 plus x over 2 equals 39. So we would go ahead and subtract 6 from both sides, because again we're trying to solve for x here. So I have x over 2 equals 39 minus 6 is 33. Multiply both sides by 2 to clear that fraction, and I get x equals 66, but this is not my answer. This is 66 years after 1970. Because remember, up here in my original variables that we were talking about, it says x years after 1970. So to find my final answer then, the year that I'm looking for would be 1970 plus 66 years, and that's the answer that I'm going to go ahead and put in my blank. Don't put the number 66 in, and this is 2036. So the number 2036 goes right here. So be careful. A lot of the models that you're going to be looking at in this homework assignment talk about the number of years since 1970 or something similar. So you always have to make sure that you remember to convert back. Now some of the problems we're going to be looking at are not as in-depth of a story problem as some of these. Some of them are a little bit more straightforward. Some of them you'll actually just be writing a formula, and that's all that the problem is looking for. So be careful. If it tells you x represents a certain value and asks for a formula, sometimes you'll just be entering a formula and not looking for a numerical response. So this one says use the 5-step strategy, which, use any strategy you want to find the number described. It says when twice a number, well, this is 2x. X is our unknown number. Twice a number is represented by 2x. Decreased by is subtract, and we're decreasing it by 8. And of course, is means equals in math, 28. So I just have a nice little equation here, 2x minus 8 equals 28. And then I'm asked to solve by adding 8 to both sides. Canceling 2x equal, looks like we'll have 28 plus 8 is 36. Divide both sides through by 2, and I get x equal 18. So I think our number is 18, but let's go ahead and check this. Twice a number would be 2 times 18, decreased by 8, and does this equal 28? 18 times 2 is 36. And again, I'm not sure if this is true. We're checking it. 36 minus 8 is 28, so 28 does equal 28, so this checks. So if you have the opportunity to plug your numbers back in to check your answers, you should always do that. The next problem is going to be similar to the one we just worked. We have to write an equation to make this go. It says when a number, so again, when a number means our unknown number, is decreased by a subtraction, 30% of itself. So 30% I could represent as 30 over 100, and I need 30% of itself. The result is 98. So here I have an equation, x minus 30 over 100 times x equals 98. So this is a number decreased by 30% of itself is 98. Now, if you are more comfortable working with decimals, I could call this 0.30 x equals 98. So this is the number decreased by 30% of itself. And it just, it's just your preference, whichever preference yours is with fractions or decimals. I'll solve this using the decimal. Here I have 1x minus 0.3x is 0.70x. And then to solve, I divide both sides through by 0.70. And so I basically have 98 divided by 0.7. Well, 98 is divisible by 7, so 7 times 14 is 98, so 98 divided by 0.7, I have to make sure that we consider that decimal, I get 140. So if I want to check this, here's 140, decreased by 30% of 140, and I'm wondering, do I get 98? Okay, so 140, and then to find 30% of 140, you take 0.3 times 140, and you get 42. And then we're checking to see if this is true, and 140 minus 42 is 98. So 98 equals 98, so this checks. So again, if you have the opportunity to check, you probably should. Now sometimes when we're asked to write equations on our own, sometimes we end up not only writing one equation, but several equations to represent a situation. So if you need to, go ahead and hit pause and read through this question before we get started. So we have a couple of different variables here. So it says, suppose the average yearly salary of an individual whose final degree is a master's degree. So we have this nice little variable m we could use here for master's degree maybe, is $33,000 less than twice that of an individual whose final degree is a bachelor's degree. Okay, so I can use B for bachelor's. It says combined, so this kind of tells me that we're going to use addition here because we have the words combined. Two people with each of these educational attainments earn $117,000. Okay, so if I take the master's person plus the bachelor's person, their average salary is $117,000. Now the word thousand is already on here, so I don't need to put comma 000, and it's already listed here in the solution as well, so I can just use the 117 part. So I have this equation, I have two unknowns, masters plus bachelor's. I need to get rid of either the m or the b and write it in terms of the other variable, and that's going to come into play right here. So from here we know that the master's earnings is $33,000 less than twice that of a bachelor's. So twice the bachelor's minus $33,000 less. So I can take this and plug it in place of m. So in place of m I'll have 2b minus 33 plus b equals 117. So all of this was just equal to m. Combining like terms, I have b's, so I have 3b minus 33 equals 117. And then I'll just solve from here by adding 33 to both sides. Negative 33 plus 33 cancels. And then I have 117 plus 33 on the right, which is 150. Divide both sides through by 3. And I get the bachelor's person earns 150 divided by 3, which is 50,000. So if we come up here, the bachelor's would be 50,000. Now to find the master's, I can just plug in my bachelor's, 2 times 50 minus 33. Well, 2 times 50 is 100. 100 minus 33, we can just go ahead and think about that as subtracting 30 to get to 70 and another 3 to get to 67. So that would be for my master's up here. Now to check this, I can just add them together. 50 plus 67 is 117, which is what I should have. So this looks like it's a correct solution. So again, some of these are kind of long problems, but don't give up on them. You have to keep working toward the final solution, and sometimes they can be fairly involved. Another type of problem that can kind of cause some difficulties are the investment type problems. So I want to make sure that we run through one of those as well. So go ahead and pause and read through this question if you need to, and see if you can get a start of it on your own. If not, you can follow through with my example as well. I think the best way to work with these types of problems is to make a table. So our important numbers are her total investment was $15,000. One part of the investment had a 10% profit, and then the other part had a 4% loss. So this word loss is important, and this word profit is important. So this is implying addition because she made money on this part. This is implying subtraction because I lost money. Now it says find the amount of each investment if her overall net profit was $380. So she made some money, she lost some money, but the overall profit was a positive value. So this, I made money overall, even though I did lose some money on the individual parts. So in setting this up, I think a table is helpful, like I said. So we have amount invested. So if we talk about the different amounts invested, we have a total that I know of. I don't know how much I have in each account. That's what we're trying to figure out. But I know in total I have $15,000. So this is my total. Okay, so now I also have interest, and this is either earned or lost. So here I have a plus 10%. I'll use 0.1 to represent 10%. And then here I have a minus 0.04%. So now we have the rate of interest, and then I also have the amount earned or lost, depending on the situation. And this is kind of where it gets tricky. Well, if I earn 10%, what I need to do then is take 10% of the amount invested. Well, I don't know how much I have invested, so I'm just going to call that X. So the amount earned on X amount of dollars invested would be 0.10X. Now this is added because it's earned. Now our next value here, if I have a total of, let's say, 5,000 invested here, that would mean 15,000 minus 5,000 would leave 10,000 for this amount. But I don't know how much is here, so I just have to subtract X instead of that value of 5,000. Now here I'm going to lose 4% of that remaining amount that's invested. So I have the amount earned, the amount lost, and the total was $380. So this is one way to set this up. There's a lot of different ways to work this problem, but this is one way. So I have an equation. I have 0.10x minus 0.04 times 15,000 minus x equals the amount earned. So what we want to do is we want to take this value of 0.04 and distribute it through the binomial. So here I'd have 0.04 times 15,000 is minus 600 minus 0.04x. Whoops, that's not a minus though. A negative times a negative is a positive. Equals 380. And then I can combine my like terms. 0.10 times 0.04, or plus 0.04, is 0.14x minus 600 equals 380. Add the 600 to both sides. And I have 0.14x equals 980. This looks familiar to a problem we just did. So we divide both sides through by 0.14. Now remember, 980 from above was divisible by 7, and it went an even amount of time, so I think it's also divisible by 14, but we need to divide by 0.14, and I get 7,000 here. So I get 7,000. Well, I know that my other account has to be then 8,000, because they have to add up to 15,000. So what was the X? Well, if we scroll up here, X was my 10% gain. So this was in my 10% gain account. And this 8,000 then was that 4% loss account. Okay, so X up here is 7,000. So the amount invested at 10%, that was the gain, that's 7,000. The amount invested in the loss of 4% was 8,000. Okay, like I said, there's several ways to set this up, but this is certainly one way that gets to the information in a table, and tables are easy to keep track of things in. Okay, let's go ahead and look at some of the other types of problems that you'll see in this section as well. Okay, our next problem deals with a round-robin tournament. It says each player is paired with every other player once, and so that means you'd play every other person that showed up to play. This function right here models the number of chess games that will be played. So if you knew you had 36 people showing up, this would kind of give us an indication of how many total games would be played that day. Now T represents the chess players, the number that must be played in a round-robin tournament with T chess players. So this is the number of people that showed up. in a round robin tournament. It tells us that 66 games were played. They want to know how many people that enter the tournament. Well, cap N is the number of games. So for our case here, we know 66 is equal to t squared minus t over 2. Because 66 were the number of games, t are the number of players. Now they want us to find the number of players. So I would just solve this like a quadratic equation. Well, it's not quite in standard form yet. I'd clear the fraction by multiplying through by 2. And of course, on the right-hand side, those 2's cancel. On the left-hand side, I have 66 times 2, which is 132, equals t squared minus t. I'd subtract the 132 from both sides because I need to get this set equal to 0. And I have t squared minus t minus 132 equals 0. Now there's several different ways to solve this. I'm going to look at this very quickly graphically to see if that's going to give me any indication of a solution. Okay, so when we're graphing this, if you're in your home screen, go ahead and hit the y equal in the top left-hand corner and hit clear if you have another graph in here. We want to go ahead and graph t squared, but we're just going to use x for our variable because it doesn't really matter which variable we use as long as it's a variable. So x squared minus x minus 132. So I'm going to double check that, make sure it's right. X squared minus x minus 132. Yep. So go ahead and hit graph. Now this graph might not show up on our screen very easily because we have this extreme value of a negative 132. So we might have to go hunting for where this looks. So let's go ahead and go to Window and X min and X max. I think that's really where we want to focus on. Let's go ahead and go to negative 50 and positive 50, and I'm just making up some numbers here. This may or may not work. Now the y scale isn't as important because I know that it's going to be a parabola opening down, clear down here, but what's more important is where is this crossing. So there's two values where this is crossing. I want to try and figure out where those are. And as I'm looking at my table, I see that these negative values are getting closer and closer to 0 in this direction. So let's go find that one. Oh, there it is. So one of my solutions is negative 11 players. Whoa! So negative 11 players is one solution. And our other solution, let's scroll up the other way. And again, what we're looking for is a trend change. Now our numbers are getting closer and closer toward negative infinity, and then pretty soon they're going to kind of bottom out and then start going up again, because this is where my parabola is at its minimum. And now if you notice, you're getting closer and closer to 0 again on the y values. And there's my other solution. So it crossed at positive 12, and then I think my other value was negative 11. So let's take those two numbers and see if we can come up with some sort of a solution here. Now this was negative 11 and positive 12, so I think on my window, let's go from negative 15 to positive 15 when I pull this graph in, just because I don't need all that extra space. And then for my y min, I'm just kind of curious where it bottoms out. I'm going to put in, let's say, a negative, if I remember right, my graph went down to something like negative 132, so I'm going to go negative 140. And those are all values that I got off of the table. Okay, so here's my graph. It's crossing. So that's what I want to go ahead and pull into my problem. Now, if any of you decided to solve this differently, you might already be done. You may have tried to factor this, and it does factor very nicely into integers. But if you're not sure how it factors and you're stuck with factoring, a good option is to go after the graph to see if you can get any indication of correct solutions, if it's an integer value or decimal values. It just provides a lot of good information. So from our graph here, we have our potential solutions, or our actual solutions, at t equal negative 11 and t equal 12. So I either have 12 players or negative 11 players that showed up. Well, obviously you can't have negative 11 players showing up, so I have 12 players as my solution. That doesn't even look like a 12. Let's fix that. So when we're trying to come up with our solution, we have to compare the numbers and see which ones make sense in the context of the question. So 12 players. Now if you like to solve this by factoring or using the quadratic formula, that's fine, but this will give me an indication as well of what my factors are. So if my root is negative 11, my factor was t plus 11. If my root is positive 12, my other factor was a negative 12. Now if you FOIL this out, you'd get the t squared minus t minus 132 back. Set both of these equal to 0 and solve. Now the cool thing about this is we already know our solution from graphing, but it's nice to verify it by hand. So these are our two solutions. However, negative players don't make sense. So I have 12 players showing up, and if I have 12 players showing up playing in a round-robin chess tournament, 66 games will be played. And so that allows you to kind of prepare in advance, I guess, for how much time that will take. So graphing helps a lot. Now, not all of our problems can be solved with graphing, but when we can, it's a really good idea to graph these types of problems. Now the next problem that we're looking at here involves a diagram, so that's really nice that they provided this to us, because this is kind of a little bit of a complicated question. Basically we have a square piece of sheet metal, the corners are cut out, and when I cut these corners out, I fold them up, these sides up that they're showing here, and it creates a box without a top. So we need these boxes without a top to have a volume of 108 cubic inches. So here volume has to equal 108 cubic inches. Now when I talk about cubic inches, that tells me right away I must have 3 dimensions. So when I talk about the formula for volume of a box like this, I have length times width times height. So I could call this length, this could be width, and then this height is the amount that's folded up. It's this little itty bitty value right here is our height. Well, from my picture, it looks like to me that length is x, width is x, so this must be a box with a square base, and height looks like it's equal to 3, and that's indicated in all those corners. And they gave me my volume as 108. So I basically have 3x squared equals 108. And then I solve from here. So I have x squared equal, 36 times 3 is 108. So 108 divided by 3 is 36. And I have x equal plus or minus 6. But a length of a box that's negative doesn't make sense, so we throw out the negative and I keep my 6. The length and the width of the open box are both 6 inches. So the diagram really helps in this case, but you do need to know the formula, the volume of a box, length times width times height, in order to solve. This next question really isn't all that difficult, but what's hard about it is getting it set up correctly. So on this one, let's go ahead and focus on the setup. Again, if you need to pause and take a few minutes to read through this, that's fine. It says a lawyer drives from her home, which is located 2 miles east and 3 miles north of the town courthouse, to her office located 1 mile west and 1 mile south of the courthouse. Find the distance between the lawyer's home and her office. Well, it sounds like to me that this town courthouse is kind of the important middle point. So let's use C to represent courthouse. Let's go ahead and use F to represent office, and then H to represent home. I don't want to use O for office because it might look like a 0 in the problem. I don't want to get confused. So I'm going to put this on a Cartesian coordinate system. So here's the courthouse in the middle. This is our origin. This is the courthouse. It says a lawyer drives from her home, which is located 2 miles east. Well, if you think about our compass here, north will head toward the top. So 2 miles east would be 2 units to the east and 3 miles north. 1, 2, 3. Not necessarily to scale here. But this is the ordered pair 2, 3 then. And she's driving to her office, and the office is located 1 mile west. Okay, so this is her home. So the office is located 1 mile west and then 1 mile south. So this is the ordered pair -1, -1, and this is her office, F. So basically what I'm trying to do is I'm trying to find the distance between these 2 points. Now I can't necessarily say where it passes through the origin or not. I don't know if she drives right by the courthouse because my scale is not great here. But I'm basically looking for the distance between these 2 points. So the distance formula, if you will recall, is the difference in the x's quantity squared plus the difference in the y's quantity squared, and then I add those together and square root it. So the difference in the x's, that would be 2 minus a negative 1 squared plus 3 minus a negative 1 squared. So again, difference in the x's, difference in the y's. Well, minus a negative is the same as a positive, so this is 2 plus 1, which is 3 squared. Minus a negative is the same as a positive, so this is 3 plus 1, which is 4 squared. 3 squared is 9, 4 squared is 16, 9 plus 16 is 25, and the square root of 25 is 5. So 5 miles in this case. And again, you want to draw a quick little picture. It'll kind of give you an orientation of what you're looking for here. Now a lot of these problems seem a lot more complicated than they actually are because of all the wording that goes with it. But if you can cut through the wording and just trying to figure out what are the basic pieces of information that you know and use a picture if one is provided, they're really not too bad. So this one says, what is the standard form of the equation of the circle? Well, before even reading the problem, I know the standard form of the equation of the circle looks like this. And so they're showing me, and this doesn't look really circular because of when I pasted this in, it kind of squished the circle, but this is a circle. This is the radius from the center of the circle to the outside of the circle. So I already know r squared is 35 squared. Now remember what h and k are. H and k are the values of the origin, or the middle, or the center of the circle. So this is a negative 2.4, comma, negative 3.9. Now remember, in our formula this says minus h, which means the opposite. So this would be a plus 2.4 and a plus 3.9. So when I put this into my formula, this would be x plus 2.4 quantity squared plus y plus 3.9 quantity squared equals r squared. Now don't put in 35 squared. I don't know if it'll accept it. You actually want to square that, and 35 squared is 1225. Quick note, remember this came from x minus a negative 2.4 quantity squared. Minus a negative is the same as a positive, and this came from y minus a negative 3.9 quantity squared. So minus a negative is the same as a positive. It's where it came from. So all this problem is talking about is writing the equation of a circle, and it's not really that difficult after you read through all the information. Now these last few problems that we're going to look at from the homework set are really important. These are perfect problems on the exam to do show your work. Now show your work problem you get partial credit for, so it's really important that you actually do show your work. So this one, solve the formula for P. So that means when we're done we want P equals stuff. So we're starting with S and Z, and it's really important that you recognize upper and lowercase letters, because my math lab will rightly count these wrong if you have a lowercase z or a lowercase s. Okay, so we want the P to stay, everything else to go. So what we want to do is first of all try and isolate the P by subtracting the Z from both sides, and that's a capital Z. So I have S minus Z equals PG. Now remember, with the P it's lowercase, that's what I want to stay. Well, what's in the way of P being by itself is the G. So we divide both sides through by G, not just the S or Z, but the entire side. So I get P equal, lowercase p equal, capital S minus capital Z all over lowercase g. So these are perfect little show your work problems that could show up on the test. And again, it's really important that you are prepared to show your work for these. I'm going to do a couple more of these just because some of them can get a little bit complicated and confusing. And so when you run across these in the homework, I don't want you to not know where to start on these. So let's go ahead and look at our next one. And this one we're trying to solve for R. So we have a capital C, and again it's important that we recognize the capital letter, 1/4 F, and then we have a parenthesis R, and R is what I want to stay here, plus z. So r stays. I want r equals stuff when I'm done. Okay, well, I think on this one a good place to start would be to clear the fraction. Multiply both sides through by 4. Now when we do that, the 4's cancel on the right, and on the left I'm left with 4 and a cap c. And then what I'm going to have to do is I need to break this r out of here, and I could do that by distributing through the f, or another thing I could do is I could divide through by f. So there's a couple different ways I could work this problem. I am going to distribute the f, but again, you could divide through by f just as well, because it is multiplied by that binomial. When I distribute this through, I have f, lowercase f times lowercase r, plus fz. Now remember, I'm trying to solve for r. So to get r by itself, my next step would be to subtract the fz. Now this one is lowercase z. So I have a 4 cap c minus f lowercase z equals fr, and r is what I'm trying to solve for. And then my final step would be to divide through by f. So that cancels. And I'm left with r equals, again, r is what I was trying to solve for, 4 capital C minus lowercase f lowercase z all over lowercase f. Now, if you did the problem the other way and divided through by f, you probably have something that looks a little bit different that's equivalent, and my math lab should accept either version. Okay, last problem we're going to work through, and again we're solving for variables, and I know I've said this a few times, but these are perfect problems for the show your work portion on the exam. So for this one we're trying to solve for r, so I have lowercase j, and again it's important that you recognize the lowercase and the uppercase, and we have r, which is I'm trying to solve for, minus p. Now this r is in the denominator. So one thing I could do is I could clear the fraction like we usually do. And again, there's several different ways to work these problems. There's not just a single way, so if you're doing it differently, that's fine. But I'm going to go ahead and multiply both sides through by r minus p. Now the reason why we're doing the r minus p is that it clears this fraction, because r minus p over r minus p is 1. 1 times h is h on the right. Now on the left, what I can do is take this j and distribute it. If I take the j and distribute, I have j r minus jp. Now again, I'm trying to solve for r, so my next step would be to add the lowercase j, lowercase p to both sides, canceling, and I have lowercase j r equals h plus jp. Again, we're trying to solve for r, so my final step would be to divide both sides through by j. Whatever you do to one side, you do to the other. And my final solution here would be lowercase r equals h plus jp all over j. And again, if it's upper or lower case is important, so make sure you note those. As usual, if you have any questions, please bring them to class. The Math Center is also open. And if you need any help, you can shoot me an email, or we can get together and talk about whatever your questions are in class. Good luck on this assignment. It is a long one, but it's very doable if you can break it down into those smaller steps.